Now we are recording. Cool. All right. So functions, let's do it. We've been using library functions, turtle.this, math.this, random.this. Those have all been made for us. Let's learn how to make our own. Before we get there, though, I want to teach you about a different kind of loop in Python. I showed you while loops. There's also a loop that starts with for. It's called a for loop instead of a while loop. And technically, this works for every other programming language too that has both. Technically, you don't have to ever use one or the other. A for loop is just as powerful as a while loop. And a while loop is just as powerful as a for loop. You can do no matter what you want. You can do anything with either. So technically, you don't ever have to use for loops if you don't want to, but I think I will prove to you that it will make your life a bit easier to use a for loop. So they are equivalent in power to while loops. That's a for loop. So let's talk about those just briefly. It might be helpful when you're working with lists. Because what for loops do is they iterate, they go through, right? They go through iterable things that can be iterated through, which is kind of like a circular reasoning fallacy, perhaps. But no, this actually works out. So an iterable thing is something that you can go through like a list. A list is an iterable thing. Like here's your list L equals 4, 5, 6. You might want to visit every element of L and like add them all up, or like multiply them together, or print them all out. A list is something that is iterable. Okay? You can pretty much pretend for the rest of this lecture that iterable things, or for the rest of this class, that iterable things are just lists. You can think about them as just a list of things that you'd like to go through. That's what it means to iterate. Okay. So, yeah, here's the syntax of a for loop. You say for, then you give a variable name. Interestingly enough, you say for x, or some other variable, whatever you want to call it. And then you say in, that's another keyword. And then you give the thing that you want to iterate through, like your list. So for x in L, for example. And then you tab over, just as normal, and you put the body here. Body goes here. You have as many lines as you want, as long as they're all indented. And it's going to let x have a chance at being every element of L. And then it's going to hit the body each time with a new value for x. This will make a lot more sense with an example, I think. But that is the basic idea of a for loop. So let's, I guess we might as well just go straight to code. Let me pull up my notes so that I remember what to correctly write. Boop. Okay, so over to idle we go, and we'll make a folder for today. Today is lecture 22, so I'll make a new file and save it in a folder called lec22. All right, so this will be called for loops, for-loops.py. And so here it is. Let's go back to the slides. I guess. So I can have a list. I have something I want to iterate through, like L equals 1, 2, 3, 4, 5, 6. And I say for, give a variable name, call it x maybe, y, z, doesn't matter, x in, and then the iterable thing, the L. L is my list. So then I hit enter, it tabs over for me. And this will iterate exactly how many times, it will iterate as many times as there are things in the list. That's the right word. So x in the body here, x gets a chance to be every element of L in order. Okay, so if I say print x, I think you can imagine that it's going to print 4, then 5, then 6. X gets a chance at being every element of this list L. It'll print 4, 5, then 6, because those are the three things in L in order. So if I run this, I will see 3 separate lines, 4, 5, and 6. Does that make enough sense? It's like go through every element in L. That's essentially what 4 is trying to say. For every element in L, call it X, print that X. You see how I'm reading that? Any questions about that? That's how that works. Okay. What if you just want to like count from like 1 to 10 or 1 to 100 or 100 to 1, do it all backwards? Those were the kinds of things that I first showed you with a while loop. I claim that for loops are just as powerful. How do you do that? Well, essentially, you make a list with those numbers. Okay? So there's a nice built-in function in Python called range. You can use it in 2 ways. You can give it just one thing. It's a function that takes just one argument, or it could take 2 arguments. If you give it just one argument, it counts up until that ending value. It's meant to be the ending value. Otherwise, it has the first number is the starting value and the last number is the ending value. They're built-in functions to Python, and it generates this range of stuff for you. It makes a list between starting value inclusive, or 1 if you give it this way, and ending value exclusive. So it does not go up to the ending value, it's 1 less than it. So if I want to make a list with all the numbers between 1 and 10, 1 to 10, then I need to ask for a range that starts at like 1, if I want to use it that way. By default, it starts at 1, and then the ending value should be 11, because it goes right up until it, not including that last value. So I'll ask for a range 111. Let me try this on the REPL. This is very unhelpful output, but you can always convert a range to a list. Give me a list of that range from 1 to 11, and that generates the list from 1 to 10. Now all the numbers from 1 to 10. Does that make sense? A range, give it a starting value and give it an ending value. It goes from the starting value to 1 before the ending value. Okay? And by default, the start is 1. So if you want, by default, the start is 0. Excuse me, because this is computer science. So if you do it this way, it starts at 0. Sorry. Got a little too ahead of myself. So if you want the list of all the numbers between 0 to 100, for example, you can do it this way or this way. You can do range 0 and 101, or you can just say range 101. So that'll generate a list of all the numbers between 0 to 100. It's always 1 less than that ending value, which is unfortunate. It's a bit confusing, I would say. So give me a range, all the numbers between 0 and 101, and to actually have the REPL printed, I have to convert it to a real list. And here is a list of all the numbers between 0 and 100. Okay, so range will generate that thing for you. It'll count. Okay, let me show you that. It also works in the opposite order. You can go downwards. I don't know if I want to show you that today, but it could take a third parameter, and that's like, I would like it to step by -1 or +2 or things like that. But let's go to code. So let's just make a blank line, and I could say for y in range, if I just wanted to print all the numbers from 1 to 10, I could say for some variable, let's call it y this time, for all the things called y in the range from 1 to 11, print y. So y gets a chance at being every value in this range. We know this means 1 through 10. And so when I run this, it will print all the numbers from 1 to 10. If I scroll enough. Any questions about that? So, let's do something slightly less trivial. Let's sum up all the numbers between 1 and 100. Okay? So we did this before. We did summing before with a while loop. Let's do it with a for loop this time. So we need a variable that keeps track of all the numbers that we're trying to add into it, right? Add into the sum variable. What we want to do is iterate through all the numbers between 1 and 100. Each time, with each value, the 1, the 2, the 3, added into sum. It increments sum by that amount, right? all the numbers between 1 and 100, adding them into sum each time. Okay? So, I don't know. I could say for x in this range, for y in this range, for z in this range. The range is now 1 and 101. That's all the numbers between 1 and 100, right? Because it's exclusive with that ending value. And I want to increment sum by that z. Z gets a chance at being all the numbers between 1 and 100. Sum needs to be whatever it was before plus this new value. And once I've added them all in, I've created the sum of all the numbers between 1 and 100. So once this loop is done, I have a value in the sum variable that I can go and print out, and it should have the right answer. Okay, let's run that. And apparently the sum of all the numbers between 1 and 100 is 50/50, which is a cute little answer. And I think that makes sense because it's 100 times 101 over 2, right? So it's 50 times 101, which is in fact 50/50. 5,050. Any questions about a for loop? Different way of looping. Just as powerful as a while loop. If you wanted to go through a list with a while loop, right, you just visit every index. So this was index 0, this was index 1, this was index 2 in the list out. You could do it that way too if you'd like. So you gain nothing, but the code looks a bit cleaner. You don't have to worry about indices if you don't need them. Am I good with that? So yeah, let's keep on trucking, and let's talk about functions now. Let me show you how to make your own functions. All right. So back in Scratch, the equivalent of making your own function was making your own block, and we essentially did the same kind of thing that we're going to be doing in Python. Each block, if you gave it something, like we could make a do thing with a number block, and every time you use it, you have to put something in for the number. Every time you use it, it like jumps up here, right? And it starts placing like the value that you passed or gave into this n, okay? The n is called a parameter, all right? Oops. Boop. So the n here is called a parameter. It's what's used inside the definition, param. And the thing that you use when you use the block that you just made for yourself is called an argument, right? Just like when you call range, give me all the numbers between 0 and 99, so range of 100. 100 is an argument to the range function. Okay, so that's essentially what's going on. In the definition, though, it's called a parameter. We need a name to talk about what we've been given, like call this ending value or something. We give it a name so we can use it. That's what we were doing here when we were defining our own blocks. So they took a parameter in the definition, and you gave arguments every time you use the block, right? And so we know how to give arguments in a function in Python already. We just know how to call it, right? You say the name of the function, you put some parentheses, and then in between, with comma separation, you give all the arguments that that function needs to run, right? Those are being passed to it. And maybe it gives back an answer, which you will save or use immediately. So that means to define a function, we need to make it so that the user can call it, right? We need to say what its name is. We need to give a name to all the things that the user might give us. Like if they give us the number 100, I better save that somewhere in in an n variable, something. It's called a parameter. I need to give that a name for every argument. Every argument needs a parameter so that we can call it and reference it. And then we have to say what happens once the user calls us with that function name, with these parameters. What do we do? What's the body of the function? Okay, so yeah, let's do that now. Let's make our own Python function. Right? So here is the syntax. You see def. Def defines a function in Python. Marks a Python function definition at the beginning of it. Then you say the name of the function, like it's being called. You give the name of your function, whatever you want to call it, func name. And then you give parentheses, just as if it were being called. You give the names of the parameters all within those parentheses. So here's my parameter 1, parameter 2, ... give as many as you need in between those parentheses, comma separated. And so these are all parameters. They will be given values when the user calls the function with arguments in those positions. And then you have a colon, as usual. When you have a body, you need a colon. And then you tab over. Tab over, and the body of your function goes here. What you want to do when you got called with those particular values of those parameters. Body goes here. And so a function is just code that gets run whenever a function gets called, right? You say the function's name, you yell at it, and it jumps up here and it starts running the body. All right? So, yeah, let's talk about that transition. And then you can put whatever you want down here after the function's done. You can have your program, and eventually you're going to call your function, right? Every time you call your function, you jump up to the definition. So we're calling this function func name, apparently. We can give it values, right? We can pass it values that we want it to work with, like maybe 42 and 43. Okay, and those are arguments. Those are arguments to our function. I would like you to do special things with 42 in the first position and 43 in the second position. All right, so the second you call this function like this, 42 gets passed on up to the function definition. And that becomes P1. P1 gets set to 42, and then P2 gets set to 43. That's how the arguments work. So the values of the parameters get set to the values of the arguments that you pass along, and then the body starts running with those particular values for P1 and P2. All right? So yeah, again, I get this messed up all the time. You will too. It's not a big deal, but parameters are the names of your variables at the function definition. And then the arguments are the values, or potentially variable names, that you give when you call the function. Okay? Every time you use it, you supply arguments. Okay? It's like you're yelling at the function definition, right? And so, yeah, the second you call a function, you can do it many times. That's the whole point of having functions. Every time you give an argument in a certain place, it jumps up here, sets the parameters to the argument values, and starts running the body with them. Okay? So, yeah, any questions before I have an example of this? There's a lot going on there, but I think an example will help. All right, so, yeah, let's make a few functions. Let's make our first function. Let's make a function that prints all the numbers from 1 to n. Okay. So every time we want to call it, it'll look like this, right? Maybe we'll give it a name, print from 1 to. And then we can give a value like, hey, print from 1 to 5. And call it like this. And that should print to the screen 1, 2, 3, 4, 5. And you can call it again with like print from 1 to 100 with a different value. But it should be generic, and we need to give an argument, right? Which means we need one parameter. Let's call that n. So we'll start the definition like this. We'll say def, name of the function, print from 1 to. And the parameter's name will be n. Okay? And then we give a body to actually do the printing from 1 to n. Okay? Then in the body, we do stuff with that n value, whatever it was. Maybe it was 5, maybe it was 100. We print from 1 to n. We can loop. Maybe we'll use a for loop. And then, yeah, let me talk about what happens when the function gets called. But let me just show it to you first. So, new file. Man, I did it again. I saved them outside the folder. I'll just do it. I'll drag them back when we're done today. Functions.py. One day I'll get it right. So, here's the name of our function. Print from 1 to. I like to call it like this, right? Print from 1 to 5, but I need to define it. Let's do that up here. So def print from 1 to, and take some value n, some parameter called n. All right, so now, whenever we call this function, we jump up here and like n got set to 5. So we better use that n value. We get to use n in here to print from 1 to n. And the goal is, like, we can call this function a million times with a million different arguments, And it'll always be, like, whatever we give is going to be set into n. So we need to generically print from 1 to that arbitrary value, okay? Whatever we got. So, all right, for x in range, 1 to n plus 1, because it's always 1 less than the last one. So if I want to print from 1 to 5, I better make a range of 1 and 6, right? 6 better be the number. Print x. There we go. Oops. Go away, zoom. There. And so now I'll call it with 5, and it should work. It'll print from 1 to 5. It should work if I make it 10. It's just going to be, it's going to take whatever value I had, plop it into n. And now it prints from 1 to 10. And I can call it a bunch of times, more than once, of course. That also works. That's what functions are meant for. Yeah, so are there any questions about what's happening here? I made a function. This is my own. It starts with def. I picked the name, picked the parameter name, all that kind of stuff. And whenever I call it, it jumps up to the body with n set to the argument. And so it can print from 1 to 5, 1 to 100, 1 to 1,000,000, whatever your heart desires, which is pretty nice. I can print from 1 to 5, print from 1 to 10, right after that. Not a problem. Oops. There's printing from 1 to 5, and then printing from 1 to 10. Why not? Okay. And so when the function gets called, Python is jumping up to that definition and sets the parameter value, or values if there's multiple, appropriately. So, yeah, when we say print from 1 to 5, like, we jump up here and n got set to, like, the variable exists here, it got set to 5, okay? And n only exists for this function, all right? N only exists inside this function. That'll become important later. N only exists, let's draw that better, inside the function. Okay, so we jumped up here and then got set to 5. Or when we call it over here, we jump up to the body again, but n got set to 10. Okay, that's the idea. So, yeah, any questions about this before I keep on moving? Okay, let's keep going. So, let's talk about giving back answers. So, I called my function by itself. Like I said, hey, print from 1 to 5, print from 1 to 10, right? And some functions are fine like that. Like turtle functions just do stuff to the turtle. You call them on a line by themselves. So some functions just do stuff, but others give back values, right? Like min2, 3, it gives back the 2. It doesn't print it, it doesn't do anything. It computes a result. Math.square root, right? If I say, import math.square root of 2, if I just call that on a line by itself, I don't see the square root of 2 anywhere. It doesn't get printed. Square root does something for me. It gives back that square root value so that I can use it in a bigger expression and then maybe print that. But the call does no printing of its own, right? Does that make sense? If I just call square root on a line by itself, it was useless. I'm not using the value that's given back to me. And that's different from this printing function, which is actually going and printing to the screen. Okay? This just doesn't compute anything. Okay? Alternatively, it makes no sense to like assign the result of print from 1 to 10 to a variable. Or like print out the answer, like this. Print from 1 to 3. And I wrap that around a print statement. That's going to get weird in a second. See the difference there? So it prints 1, 2, 3 because it does call the function. It's going to print from 1 to 3. But then it prints whatever this thing gives back. And it gave back nothing at all. So it prints none. Okay? So the function gives back none. Whatever that means. It gives back nothing at all. It's just a function that goes off and does something. All right, so that's a big difference, but it still might not be very clear. All right, so let's talk about the min function. Kind of similar to square root. So min, for example, gives back the 2, right? When you call it with 2 and 3, the minimum is 2, and you can set x to be the result. So the min function gives back something. You can use it, set it to a variable, involve it in a larger expression, all that kind of stuff works out just fine. Because the whole point, this function gives back an answer, it's going to be replaced with its answer. So like print min23 plus 1 is going to print 3 because min23 will be replaced with just 2. Right? It's like this goes away and becomes 2 somehow. And then it does the 2 plus 1 and that becomes 3 and then it prints that. It gives back a value and we can use it. All right? Assigning the result of a print function call makes no sense though. Like what is print? Does that give back a number, a value? No, it gives back nothing, okay? There's no need to assign it to a variable called x, okay? That's the idea. So, does that make enough sense? Print also gives back nothing. Let's use the REPL for that. It's like x equals print hi. It prints hi because that's what print does, but it gives nothing back. And x, like I ask it for the value, what is x? Print x. It's nothing. It's called none. That's the word for nothing in Python, right? Also, it makes no sense to like add the results of printing blah and printing foo. That'll be a runtime error, in fact, because those values don't give back anything. And they for sure don't give back numbers. They give back nothing at all. They give back none, okay? So sometimes you want a function that just does something and is meant to be called on a line by itself, like this one, our print from 1-2 function. Sometimes we need a function, we want a function that gives back an answer so that we can compute something larger with it and then eventually print that final answer out. Okay? So if you want to give back a value to whoever calls your function, then you use return. There's a keyword called return, okay? That is the idea. You can use it in bigger expressions like min23 plus min or plus max23. Why not? Max also exists. This will give back 2, this will give back 3, and then it will result in 5, right? Because these are returning the smaller of the two. This is returning the bigger of the two. So, yeah, let's make a function that returns them. Let's make a max, or not max. Let's make a sum function. Let's make a function that just takes 2 numbers. It's a very silly example, but it should help, I think. It's going to take 2 numbers, like we're going to call it sum. It'll take 2 numbers like 2 and 3 and it just adds them together. So it's essentially a function that wraps around the plus operation. Okay, so it'll give back 5. It won't print it, it will give it back. All right, and the point is I could use this in a larger expression. Like I could say sum 2, 3 times 2. And that should give back 10. I can build up something even bigger with that. Okay, there's a huge difference between returning and just doing something. All right, so the sum function will take 2 numbers and return, give back their sum, and hopefully that will help. All right, so yeah, let's make this happen. So I'm going to make a function called sum. Print, let's have an empty line, and then I'll make a function called sum. There. Def. So I want to be able to call it like this, right? Sum 2, 3, but I want to use that in a larger expression because it gives something back. So like print sum 2, 3 times 2. So it's going to be def sum, and it's going to take 2 arguments, right? So it needs 2 parameters. I'll call those x and y. So we want to add together x and y, whatever they were, okay? So what we need to do is say return x plus y. Give back the answer of adding x and y together. All right? So you say return blah when you want to give back blah to whoever called you. to whoever called this function. All right, so we're calling sum down here. It should give back 2 plus 3, because 2 is going to be set to x, 3 is going to be set to y. It should give back 2 plus 3, so 5. And we'll multiply that answer by 2, create 10, print that. Okay? It's a big, big difference between this and this. I hope you'll see it if you look at it long enough. So there we go. We get 10. Cool. Are there any questions about the sum function? It's a very silly, simple function. I hope it makes sense to you. And this one gives back a value, and you better use that. If you want to print it, you have to wrap that around a print call. So like I could say sum 5 and 10, which will compute 15, but watch. It does not output 15 because there's no printing. It computes it, it doesn't print it. Right? We are not, it kind of throws away the answer. We're not doing anything with this result. Sad face. You should. Let's see, yeah, so just like you have to, you can't use a function that doesn't return something in a larger expression. You must use a function that returns something in a larger expression if you want its value stored or used. Okay? I hope that makes sense. So yeah, you gotta go and you gotta print it. Print sum 2, 3. Then that'll give you your 5. Or print sum 5, 10. Then that will finally give you your 15 that you were trying to get at. There it is. Okay? Let's see. I think that's what I want to say there. Yeah, so, okay. Yeah, when you return a value from a function, the original function call gets replaced with the value if it gives something back. So this is getting replaced with 5, makes 10. This is getting replaced with 15. We did nothing with it. This is getting replaced with 15, and then we're printing 15. That's why that's working. All right? So when you don't return something, you can't use the result. You can only just call that function on a line by itself, like we were doing with the print from 1, 2 function. It can only be called on a line by itself. Okay, so let me demonstrate like calling functions and returning from functions. Hopefully that'll make some sense. All right, so let me draw for you what's happening when we run our functions. Okay, so let's pretend we're trying to run this line here, print sum 5, 10. All right, we're trying to run this right here, and so there's a nice diagrammatic way to explain how code is running that's called using the stack. There's like a stack of work that needs to be done. You can only do the topmost thing. It's like a pile of papers. So let me draw what's happening for you. So like when our program starts, we are running all of the unindented code, right? We're running these print lines, creating functions. So we start our program with, what work do we need to do? We need to do the outermost code. Outermost code. And then, eventually, we're going to get here, right? We're on this line, we're trying to run it. So it's a print call. We have to call print. So there's some work to be done there. Print is the next thing that needs to happen. But print needs the answer from sum first before it can print it, all right? So in order to remember what needs to happen, there's this concept of adding work to your stack. So print needs to call sum. And so this is like a diagram of who's waiting on whose result. So sum needs to complete so that print can print out that sum so that the outermost code can continue with any lines that are down here. ... All right, I hope that makes enough sense. So yeah, when we call sum has its own variables, by the way. It has its parameters. We jump up here to the definition, and the x and the y, they're set to 5 and 10. So sum has an x set to 5, and then it has a y set to 10, and it computes its answer, right? Sum goes off and it returns x plus y to whoever called it. Who was asking for it? Well, it was just the person below it on the stack. That's what the diagram is good for. So this gives back 15. And then sum is like done with its work and it goes away. Now we're back inside of print. That's how you read the diagram. It'll make more sense the more I do, the more I draw for you. Then print goes off and it computes, or it performs its work of printing whatever was given to it. It knows that it's got 15 now and it needs to print that. So it goes off and, like, here's the terminal screen way over here. It prints its 15 to the terminal screen. And then print's done, and it's down in the outermost code back with whatever the next line is. That's essentially how it's executing. Does that make any sense at all? So sum gives back its answer so that the code below it, the print function, or just the main code in general, has access to the value that it gives back and can use it in larger expressions like this one. Sum 2, 3 times 2. Okay? That's the goal there. So let me give you an example of a function that you will probably write on accident. If I ask you to write a sum function, you might accidentally print instead of return. Let me show you what happens when you do that. So let me make a function called SumBad. It takes x and y again. It's not going to return. What it's going to do is it's going to print x plus y. So it kind of does the work, kind of doesn't, right? So this function is incorrect. Compare it to the original sum function. It's just printing. It's not giving back the answer, okay? So if I call it, like SumBad 2, 3, it actually will print something, but we're expecting it to work like this, like print the result of SumBad 2, 3. Watch what happens. Now let me have an extra line break in between. But look, it prints 5, which is, like, it calls this function and it prints its 5, but then it prints the result of that, which was nothing, none, okay? Because this essentially gets translated into, it gets replaced with whatever it gives back. It gave back nothing, so it's essentially a call to print none. Does that make sense? And so that means, because it's not actually giving back a value, you can't use it like you might expect, like up here, right? Sum 2, 3 times 2. You can't do SumBad like 4, 5, and 6. The same arguments still don't work anyway. But this is definitely not going to work. And look at why. This actually gives you a runtime error. It's like, I don't know how to multiply none by 6. None in it. And that should make sense given the context of what we've been saying, because SumBad just prints out its answer, like it prints 9, but it never gives back that answer. That's what we really wanted it to do. So this gets translated into, this gets replaced with whatever it gives back, which is nothing. This is essentially a call to print none times 6, and that of course makes no sense to Python, and it yells at us. Does that make sense? You must return if you want to use that value in a bigger context, like here. This is a bigger context. Our original sum works just fine because when you return something, that's what it's getting replaced with. Are there any questions about this? This is definitely an example to study. It's a bit subtle, that's for sure. So yeah, let me try and explain to you like why that was wrong. Let me draw you a stack diagram. So we were in our outermost code. And then we called print, right? And print was waiting on SumBad of 4 and 5 to complete so that it can then multiply it by 6, all that kind of stuff. So it was waiting on a SumBad call, which took an x and a y, they were 4 and 5, right? And so it computed 9, and it printed 9. There's the terminal screen over there. It printed 9. But what did it give back to print, who was waiting for its result, waiting for something to be given back? It gave back nothing. It gave back none. Okay. And then it's like, I'm done, back to print. That's the difference. Giving back something versus giving back nothing. Any questions about that? So, oops. Hopefully with enough times of me explaining it. It will sink in. All right, ready for another example? All right, so let's do one that sums all the numbers from 1 to n. So instead of printing them out, let's sum them. Let's see. How do I want to do this? I'm going to be making a couple summing functions, so I'm going to make a new file for that. I'll call it sum functions.py. All right, so let's make a function that sums all the numbers from 1 to n. So instead of print from 1 to n, we'll do like sum from 1 to, and then like we'll give it 5. And so that's going to compute 1 plus 2 plus 3 plus 4 plus 5 and give it back, right? Return. So that should become what? 8, 9, 10, 15. So a call to sum 1 to 5 should give back 15, right? And then, yeah, here's how we'll do it. We'll call it like this. Sum12 takes a value n as its parameter. We'll start off a sum variable at 0. We'll calculate our sum and then return it. All right? And here's how you'll calculate that sum, just as we did. Maybe we'll use a while loop this time. We'll be like, let's start a variable, a counter variable, call it I or something. Start it at 1. You can totally use a for loop though, now that you know how. And while I is less than or equal to our n, whatever it was, maybe it was 5, then increment our sum by I. Sum equals sum plus I. And then advance I so that the next time we come around, we're adding like 2 in instead of 1. 2, then 3, then 4. Okay? So, yeah. We have our sum variable. It starts at 0, and like we want to have an I variable that starts at 1. And continuously adds in that 1 into sum. Then the next time we come around, make I2, add the 2 into sum, make it 3, make I3, add the 3 into sum, now it's 6, dot, 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 dot. Okay, so for as big as n is. All right, so yeah, let's make this sum12 function, and it's going to return its sum, so I can use it in a larger expression. So I could say something like sum 1, 2, 5, and then just immediately go back and like take that number and multiply its answer by 3, right? And so this, in this larger expression, is going to get replaced with the 15 that its result will give back. And this should compute, finally, 15 times 3, which is 45. Does that make sense? That's why we want to give stuff back, so we can use it in a larger context. All right, so let's make that sum12 function. I want to do it like this. I want to print sum12 5 times 3. So I should print my 45. So def, let's go over here. We've essentially written the function. Def sum12, sum number n. Sum starts at 0, and then I want to calculate the sum, and then eventually return that sum that I built up. And then here's how I do it. Start I at 1, while I is less than or equal to n. Advance sum by that amount, by I, incremented by I, and then increment I by 1, so that the next time I come around, I am adding in the next number, like the 2, the 3, the 4. Right? And then finally, I have the answer. Once the while loop is complete, give back the final sum to whoever called us. And so if we run that, it will indeed compute 45, because this will get replaced, because it's returning. This will get replaced with 15 times 3. Are there any questions about that? All right, so if we're okay, I have a question for you now. So instead of this one, and I'll leave this one on the screen, I would like you to make a sum odd 1 to n function, right? So instead of returning 1 plus 2 plus 3 plus 4 plus 5 all the way to n, return 1 plus 3 plus 5 plus 7 plus 9 all the way to n. Sum only the odd numbers from 1 to n. So like if you called this with sum odd 1, 2, like 7, it should compute and create 1 plus 3 plus 5 plus 7, right? All the numbers between 1 and 7 that are odd. And that will compute 10, 16, which is, for a fun reason, 4 squared. So yeah, think of how you would do stuff and try to create that sum odd 1, 2 function using this one as a guide, right? See if you can get it so that it will give back the right answer. I'll give you a few minutes to try that. All right, that is my timer. Did any questions come up while we were trying this? Because it really is a very short change, right? How was I getting the 2 from the 1 and the 3 from the 2 and all that? Where was I doing that in this code? So I want to change that. Don't go from 1 to 2, but go from 1 to 3. What line needs to be changed? I think I heard it mumbled. So here is where we're incrementing I. I is going to give us the next thing to add into sum, right? That was this diagram here. So if I increment I by 1, the next thing to add into sum is 2. But if I want to add just the odd numbers, I want to increment I by 3. Or sorry, 2. Excuse me. So the next time after 1, it will be 3. That's what I'm So instead of I plus 1, say, or I equals I plus 1, say I equals I plus 2. And that will take I, if it started at 1, the next time around it'll change it to 3. I'll only consider the odd numbers at that point. Does that make sense? That's really it. So, I don't know. Let's not do that. Some odd 1, 2. Then. And so the only line that has to change is this one right here. I equals I plus 2. That will correctly range over the proper values. And so I want to say like print some odd 1, 2, like 7. And so the answer is going to be 16. It'll print out 16 because I gave it back. But the whole point is to be able to use that in a larger expression, right? 7 times 2. Now it'll print 32. Does that make sense? Any questions about why it's doing what it's doing? And the whole point of functions in general is so that you can call them multiple ways. Also, it should give back the same answer if you do some odd 1, 2, 8, I believe, because it'll like go between 7 and 9, and like immediately 9 is greater than 8, just like 9 was greater than 7. It will never consider the number 8 because that's even. So it'll just like skip over it. So both of those will return the same thing. But that's just an aside, because the whole point of a function is to be able to call it in a bunch of different ways, to have this code be reusable and reused by a bunch of people. Okay? That's the idea. So yeah, some odd 1 to 8 is still going to compute 1 plus 3 plus 5 plus 7, because you can't go to 9, that's bigger, right? It'll give back the same answer. And that should be the correct value anyway. So yeah, the moral of this story is that like we really like to reuse code. It's better than copying and pasting it all over the place. That's the reason we learned about loops, and that's the reason why we're learning about functions. Functions are extra good for this. All right, so combine loops and functions, and you have a very easy to read program. All right. So the very last thing that I want to show us today is a bit of a vague concept. It's kind of difficult to understand, but there's actually 2 different kinds of variables in Python. You've seen both now, but it's just not obvious, right? So let me tell you the difference. They are global variables versus local variables, right? So most of our variables have been global so far. So I'll call this file locals versus globals. So when you make a variable outside of any function, like we've been usually doing, that makes a global variable. That's what it's called. It's a global variable, and everybody has access to it. Every function, everybody from then onwards, even the outermost code, right? If I say x equals 42, everybody for the rest of the program gets to see that x and use it, right? It's visible to everyone. It's a global variable. It is visible to everybody. Okay? And so I can like use it later, print x, of course. I can use it inside of a function if I want to, and that's the goal. All right. So it's a global variable. If you make a variable inside of a function, though, it's a local variable, and only that function gets access to it. Okay. Only that function can use it, and also your parameters, those count as local variables. So for example, that's why I said way up here that n only exists inside of this function. If you tried to use n outside of the print from 1, 2 function, like Python wouldn't know what you're talking about because n doesn't exist. It only exists inside of the function. All right. So if you make a local variable, if you make a variable inside of a function, or try and use a parameter, it is a local variable. Only the function has access to it, and parameters are local variables. Okay. So let me show you that. Make a silly function called blah, takes no parameters, and I don't know, I can make a variable called y. This is a local variable. It only exists inside the blah function. I can totally be like, I don't know, print y times 2. And because x is global, x is visible to everybody, including this function, I can use it. I can be like, print, I don't know, x times 2. So x still exists in here. X exists everywhere, so it definitely exists in here as well. Because it's global. But y only lives inside of this function. I can only use it inside of blah. So this is going to, if I run it, should be, no, let's also call the blah function, excuse me. If I run this, it's going to do what you would expect. It'll print the x, then we call blah, so we jump up here, we print x times 2, x is a global variable, so we print 84. There it is. And then y we set to 3, it's a local variable, but I'm using it still inside the function, so there I am printing y times 2, which will print 6. Okay, so that's obvious. That's stuff that kind of makes enough sense. But watch what happens here. Let me... how do I want to show you this? Let's actually draw the stack first, because x is a global variable. It exists in that outermost code, right? Here's where x lives. This is really, I should be drawing boxes inside of boxes to be perfectly accurate. Here's your outermost code. And here's x. It was set to 42, right? That's a global variable. It lives in the outermost code. Then inside of blah, when I call blah, like I call it right here, now I jump inside of it, I add it to my stack of work to be done. It defines its own y variable, right? What did I set that to? 3. I can use it while I'm in the blah function, but the second the blah function is done with, and we go back to the outermost code, like this returns, we go back down here, y no longer exists. Okay, that's what it means to be a local variable. So, if I were to do this, print y, out here, after blah has finished, I'm not inside the function anymore. I try and print y, it's not a global variable. I get an error. Y is not defined. It only lived inside of blah. Does that make enough sense? Any variable that you create inside of a function is a local variable. It only lives for the life of that function call. All right? So like a new y gets made every time you call blah. That's a corollary of that fact. Okay? So, the one last weird quirk of Python that I need to tell you about, this doesn't exist in every language, but if you're inside of a function and you want to set a global variable, you can just reference x if you want to use it, like here I am using the global variable x. If you'd like to set a global variable called x, if you'd like to set x inside of blah, then you have to tell Python, hey, I'm about to assign to a variable that is a global variable. Don't make a local variable for me with the same name. Please reuse that global variable. I want to set into it. All right. You say, usually at the start of the function, you say global, the name of the variable that you'd like to set. All right. And that is so that you can do this. So you can say, let's do it here, I guess. No, let's do it before I print it. Let's do it up here. If I want to do this, x equals x plus 1, by default, it's going to be like, I don't know what you're talking about. Local variable x, reference before assignment. Because it thinks that that you want to make a variable called x and like overshadow this one, like make a brand new variable also called x. You just got to tell Python, hey, I want to use the global variable called x. I want to set it inside of this function. So you just say global x before it. That's telling Python, hey, I want to modify the global variable x, right? And then this line would change it. And then everything's well and good. That's all. So yeah, x equals 42, print the 42, call blah, we jump in here, we say global x, so now this line makes sense and it sets it to 43, and so that means this is now 43 times 2, which is 86. We print that, y is 3, print the 6 because y exists inside of blah. That's an okay thing to do. Then blah is done. We're down here running the rest of the code. We try to print y, which is not a global variable. It was somebody's local variable, but it's no longer in existence. And then we get our error. Okay? So a lot going on there. I hope it made enough sense. But you will see this again in future examples. That's for sure. Any questions about any of this? So we came a long way today. We learned about how to make our own functions. Now we can do that. We can make our own libraries for people now. Isn't that cool? We use a bunch of code. I believe you can. This is it's like a statement in Python. It needs to be its own thing. It's the same reason why you can't say like x equals 5 and y equals 7 on the same line. Like that doesn't make sense to Python. It's like, what are you trying to do there? You might actually. There's something that you might be able to do, but I'm not sure which thing it is. It could be a comma. I don't think they use semicolons in Python, but it's something like that. There's a way to get a bunch of things on the same line. Yeah, it's its own little thing. You can think of it as like a function call or something. It's like not giving back x in a sense. Yeah, it's its own little statement. That's a great question though. But I do have a feeling there is a way to do it. I forget how. It's like maybe a comma, I think would be the right thing. There's a way to separate a bunch of things on the same line, and that would be what you need here. Look that up together. Any other questions? Because I think, no, actually, there's nothing to release. Let's try it now. Python, multiple statements on one line. How do you do it? Dun, dun, dun. Is it semicolon, really? Let's find out. Wow. Python has semicolons. Good to know. All right. If you wanted to do it that way, use a semicolon. This should make more sense to my C++ programmers, but that's crazy. I wouldn't have thought. Separated by semicolon. All right, but yeah, once you add like if statements and stuff, you can't put all those on one line. Then indentation is a problem. But yeah, if they're just simple statements like this, I could have done global x semicolon x equals x plus 1 all on the same line. Good to know. Nice. All right, so yeah, I think that's all I got for us today. If we're good to go, let me stop recording.